So today we're going to be going through the 2021 external exam for mathematical methods, the technology free multiple choice component. So feel free to pause this wherever you need to. Okay, so question 1. Nice basic log question, love a log question. Okay, so first thing we've got to remember is to get it from this form, because at the moment it's got nothing out the front of it. It might, doesn't have to. So when that comes up, he's going to come over here as a power. Now, logs work in the reverse way to index laws. So normally if you had two things dividing, you would subtract your indices. But here for logs, when you have two things subtracting, it means you're going to divide these components here. So first thing I'm going to do, I'm going to move the 2 above the x squared. So it will become log base 10 x to the power of 2. Now, because they're dividing, we divide the parts in the brackets, not like this. Okay, so next thing that we need to do is we're going to simplify what we've got here by cancelling out our x's. So that one will cancel with that one, and I'm left with log 10 bracket x over 3. So that would make our answer A. Now for part 2, or question 2, the table shows that a technician has spent the time that he spent servicing photocopiers. What is the probability that a given service required at least 10 minutes, but less than 20? So if I'm hiring someone to do a job and I say you need to be here for at least 10 minutes, that means the least amount of time that you can be there is 10, okay? But you have to be there for less than 20, means you're not including the 20. So now we're going to pick the frequencies that correlate to these pieces of information. So this one here will include the at least 10. And this is all the way up to, but not including the 20. If it was including the 20 as well, I'd have to add this one in too. So now I've got 70 over, when I add all of these together, I'll get 200. We can see that they're decimals, so we want to get it as over 100, which would convert nicely to B. C, we're going to be integrating. So when we integrate this function here, I'll end up with the 10. Remember, that just stays out the front. E to the power of 4x, because the power above it doesn't change. The derivative of this will come down and divide the function. So divided by 4. So if I simplify these two out the front, they both have a highest common factor of 2. So I can simplify it to 5 over 2 e to the power of 4x plus c, because we integrated it, relates to c. Okay, number 4. The second derivative of a function is given by this. The interval on the graph for which this is concave up is here. Now we can see that these are all have 0 in there, so we're going to substitute 0 in to see what's happening. So f double 0 equals 2, 0 over 1 plus 0 squared. So when I substitute 0 in, I'll end up with 1 over 0, which is equal to 0. So that would imply to us that that is a point of inflection. So I'm going to pick a point, either left or right, to see what's happening, okay? Because it could be looking like this, but that's my point of inflection. It could be looking like that, where that's my point of inflection. It could also be doing this. So we just need to see what's happening. So if it's going to be, let's say we're going to substitute in now positive 1. So 2 times 1 is equal to 2 over 1 plus 1 squared is going to be 2 divided by 2 is 1. So then that is positive. Remember, when we're positive, that makes a happy face. And when we make the happy face, the arrows are pointing up, so it's concave up. Okay, so that means that it's not going to be including 0, because at 0, that's the point of inflection. So as we're going this way, it's going concave up. So that means the 0 is the littler one in that expression. So that correlates to C. Okay, now this is a solidly good question. The graph of the second derivative is shown over here. Which of the following could be a graph of the first derivative? Now, first thing we need to recall is if this is a parabola, that means that the first derivative of this was going to be a cubic function. So when I'm looking down here, I can straight away disclude the first two because they are not cubics. So it's not U and it's not U. Now, at C and D, they're the two that we're looking for. So let's go back and search through for some more information. Now, there are stationary points here and here. Stationary, cubic, stationary points at 1 and -1. So let's go down and see if that aligns with the piece of information that we've got. So here we've got a stationary point, -1, good. Stationary point at 1, also good. Here at 1, here at 1. Okay, so that doesn't help us because that fact fits both. Let's look for our next piece of information. So if this is the second derivative, then all of the area between here and here, so between -1 and 1, the gradient is decreasing. Now, the way I know the whole gradient's decreasing is because this is showing as negative space on the y-axis. So let's go down and see which piece fits that information. So we're looking for the one where between -1 and 1, the gradient is decreasing. So that fits D. So that is the graph that will show the first derivative of that second derivative. Question 6. So a random variable x is the number of 6 trick question. So we're going to be doing binomial distribution without using our calculator. So here, if this is random variable x, successes of the Bernoulli experiment with n trials. So here we can see that it goes up to 4, which means the maximum number of successes that we can expect is 4. So n is going to be equal to 4 trials here. So that instantly counts out C and D, meaning that the QCAA supplied answer is incorrect. So next thing that we can look at, probability of P and Q. So this is successes and this is the failures. Distribution is shown below. Now we're going to test these values. So we already know that n is equal to 4. So if I start by writing out my formula for binomial distribution, because you're given this table of values, which means that it's now part of binomial, even though it's from a Bernoulli experiment. So, and that should be R, P to the power of N, P to the power of R, and then it's Q, the successes to the power of N minus R. So we know that N is 4, so 4 over, then we're going to have our probability in here, the power of, we haven't got a value down there yet, so I'll just erase that. Times whatever this is, 4 minus whatever R is. Okay, so here's the problem that we have when you guys just go through and test values. If you first start testing and you let n equal 0, you get the answer of this one for testing them. So you can get either answer using n equals 0 or n equals 4 because of the way that the formula works. What you need to do is you need to test n equals 1 to break up the tie between them of it could be this or it could be that. So we're going to test n equals 1. So that means this is going to be 1, so this is going to be 1, and then 4 minus 1 here. Now the next thing we're going to do is we're going to draw out Pascal's triangle to figure out this first section. So I need to go down to the 4th row. So that's first, second, third, and 4th. So we're looking at the 4th row, first position, remembering that this would be 0th position. This is the first position. So this part here can be evaluated as 4 times. We're going to substitute this first one in, If we don't get it to match this, then that means that this is our answer, the one below it. So we're testing A. If A is false, then the answer is B. Okay, so 2 over 3. 2 over 3 to the power of 1 is just 2 over 3. And then the next part is we're going to input 1 over 3. And it's to the power of 3. So 1 to the power of 3 is just 1. 3 times 3 is 9. Times 3 again is 27. Okay, so now we're going to simplify what we get and see if we can make a nice answer. So every number is actually a fraction over 1. So 4 times 2 makes 8, times 1 is still 8, over 1 times 3 is 3, 3 times 27 is going to be 81. Remember, if you don't know how to do that straight away in your head, write out a little sum. 3 times 7 is 21, 3 times 2 is 6, plus 2 makes 81. Okay, so that does match this one here, meaning that P is going to be 2 over 3 and Q is going to be 1/3. So A is your answer. Next one, integrating this function here. So first thing I'm going to do is integrate it. When I do that, it'll become 2x to the power of 2 divided by 2 plus 3x between 3 and 1. Now I'm ready to substitute my values in. Those two will cancel. So 3 squared is equal to 9, plus 3 times 3 is also 9. Subtract 1 squared is 1, plus 3 times 1 is 3, so minus 4, and that's going to give me an answer of 14, because 18 minus 4, 14. Your answer is C. Okay, number 8. Continuous random variables have the probability density function given below. The mean of x is this. Now, this is another formula that's given to you on your formula sheet. So if you quickly look at it now, you'll see that the formula looks something like this. The mean is given to you as the integration of x times your p of x function dx. So for us, that's going to mean that we're going to integrate x multiplied by 3 over x squared dx between 3 over 2 and 1. Now, the next thing that we want to do is we're going to simplify our function before we integrate. So I'm integrating now 3 over x. And when you integrate 3 over x, think about it as 3 times 1 over x. Okay, that'll stop you from making mistakes. So when I integrate this, I'm going to end up with 3 ln x between our boundaries of 3 over 2 and 1. Now I'm ready to substitute my values in. So 3 ln 3 over 2 minus 3 ln 1. Okay, so now, next thing I'm going to do is I'm going to, well, if I think about ln 1, that's actually 0. The reason why that works is because when we're using ln, we're saying what is the power that would be above x so that it's equal to 1. Now, the only thing that will give me 1 is 0, meaning that ln 1 is 0, so that n term disappears. So now I've got 3 ln 3 over 2. This will come up and act like a power. So now I have to multiply all the powers on the inside of the bracket by the one on the outside. 3 to the power of 3 is 27. Do it on your fingers if you don't believe me. 2 to the power of 3 is 8. So that's going to be B. Okay, a basket contains 10 green apples, 30 red apples. 3 apples are drawn at random from the basket with replacement. Determine the probability that exactly 2 of the 3 apples are green. Now, it doesn't indicate to you here that this is going to be an application of binomial expansion, but it is. So let's define our variables first. Now, we're going to be doing 3 trials. Out of the trials, we want 2 successes. The probability of a successful green apple is going to be 10 out of the total, which is 40. So that'll be 1 in 4. And your probability of failure is going to be 3 in 4. Okay, so now I just plug it into the formula that's given to me on our, formula booklet. p to the power of r, and then it'll be q to the power of n minus r. So 3 over 2, oh wait, sorry, the combination of 3, 2, 1 over 4 to the power of 2, and 3 over 4 to the power of 1. Okay, so again, I'm going to quickly sketch up Pascal's triangle to the third row, because this means we're looking at row 3, second position. So 1, 2, 3, and then we're going, that's 0, 1, 2. So this one here is the one we're using 3 times. Now the power on the outside multiplies all the powers on the inside. So 1 squared is going to be 1, 4 squared is going to be 16 times 3 over 4. So that's going to give me 9 over, now quickly let's just work out 16 times 4. 4 times 6 is 24. 4 times 1 is 4 plus the 2 will make 64. So my answer for that one is going to be B. Now, I can see all of these are going to be over 64, so I know that that base is definitely correct. This is also the correct answer. I checked before I did this. Okay, lucky last question. So, handspans of teenagers are normally distributed. Remember, the normal distribution looks like this. Whee! Okay, where your mean falls in the center, and then you've got a standard deviations to the side. So that's 1 standard deviation, 2 standard deviation, 3 standard deviations. Yeah. So handspans of teenagers are normally distributed with a mean of 15. So the mean is going to be 15. Standard deviation of 2 means each time we're going up this way by 2 and down this way by 2. So 17, 19, 21, 13, 11, and 7. Now, if we look at the different bands that it's asking, which is expected to be the largest group, 7 to 11 centimetres is very short. It's not going to be that one. 11 to 15 is definitely bigger than A, so that's correct. Teenage with a handspan between 13 to 17. So we can see the distribution between 13 and 17. The area between here versus the area in here is definitely larger, so it's not B then. And the handspan between 17 to 21, again, this area in here is tiny. So our correct answer must be C.